Buldhana district in the Vidarbha region of Maharashtra state is world famous for the Lonar crater. Now it will also gain attention for having the first of its kind regional rural water supply scheme with automation, the Jalgaon Jamod town and 140 villages regional rural water supply scheme. There are around 140 villages in Jalgaon Jamod and Sangrampur talukas of Buldhana district, which were known as salinity-affected villages. Groundwater sources here had hard saline water. People were suffering with kidney and other diseases. Hence, to provide pure and safe drinking water to the people in all these 140 villages, Maharashtra Jeevan Pradhikaran Circle, Akola, and Urban and Rural Scheme Division Buldhana planned a scheme named Jalgaon Jamod Town and 140 Villages Regional Rural Water Supply Scheme, considering the Van Dam as a source. The work of designing, construction and commissioning with a trial run was awarded to Messrs. The Indian Hume Pipe Company Limited, Mumbai, a company established in 1926 with rich experience of 95 years in the field of water supply, sewerage and irrigation. The total contract value of the project was 165.99 crore rupees. This scheme was designed considering the population up to 2030 and was intended to serve more than 4 lakh people. The daily water demand for 2030 was calculated as 22.34 million cubic meters. Hence, for the first time in Maharashtra, PLC and SCADA system-based operations were introduced in the Regional Rural Water Supply Scheme. This scheme covered a total of 140 villages, 64 villages from Jalgaon Jamod Taluka and 76 villages from Sangrampur Taluka. The total project was divided into 16 zones for better operation and maintenance. The project was designed in such a way that the water was distributed by the flow of gravity for 81% of the population and by pumping for the remaining 19% of the population, making it one of the most techno-economical water supply projects. Intake of raw water was taken from the canal of the Van Dam on the Purna river, where pre-stressed concrete cylinder pipes of 700 mm diameter were used for 1780 meters as a raw water gravity main from a sump of 2 lakh liters capacity to the 31 million liters per day water treatment plant or WTP. After water treatment, the network of pure water distribution consists of a principal gravity main line from the WTP to the master balancing reservoirs or MBRs using PCCP pipes of different diameters varying from 1000 mm to 600 mm for a length of 46.12 km. 13 MBRs with a capacity varying from 650 kiloliters to 50 kiloliters. 1 ground servicing reservoir or GSR with a capacity of 150 kiloliters and 1 sump cum pump house constructed at Tunki village with a capacity of 250 kiloliters. Ductile iron, that is DI pipes varying from 200 mm to 350 mm diameter and high-density polyethylene, that is HDPE pipes varying from 110 mm to 200 mm diameter were used for a length of 437.91 km for the pure water gravity main from the master balancing reservoirs to the elevated service reservoirs or ESRs. 50 new ESRs were constructed and the 90 existing ESRs were connected with HDPE and DI pipes for smooth distribution of pure drinking water to each village. 75 mm to 200 mm PVC pipes were used for the local distribution of pure water in the villages for a length of 118.95 kilometers. Sectional hydraulic testing of the laid pipelines was successfully done during the execution to ensure quality work. Automation and SCADA was another highlighting aspect of this project. The Indian Hume Pipe Company Limited had designed the automation of this project with the most advanced technology, and thereby everything was automated and scheduled, right from raw water to distributing pure water to the doorsteps of 140 villages at their specified time. A flow meter was installed at the raw water intake location and data communication to the WTP control room was done through GPRS modem connectivity. A butterfly valve with an actuator was installed at the raw water inlet of the WTP to regulate the flow of water as per the requirement through the SCADA system. A water treatment plant of 31 million litres per day capacity was constructed with the advanced feature of PLC and SCADA-based operations. All the quality parameters of water such as pH, turbidity and chlorine content are sensed and monitored through the SCADA system automatically. The operation of the flash mixer, clariflocculator, backwashing, cleaning of filter beds, wash water recirculation and chemical dosing is automatically managed through the SCADA system by using the appropriate logic as per the process requirements. All valve actuators, pumps and air blowers are controlled and operated through the SCADA system. A pure water sump of 9 lakh litres capacity was constructed at the WTP site. It has an ultrasonic level transmitter and an ultrasonic flow meter at the outlet of the sump, and it is interfaced with the PLC and controlled through SCADA. Once the MBR and GSR are filled, the water level in the pure water sump at the WTP goes down. An ultrasonic level transmitter senses the water level in the sump and gives the signal to the PLC for operation of the inlet valve at the water treatment plant. A pure water pumping station located at Tunki village has a PLC controller and a SCADA system. This PLC and SCADA system manages the pump operation automatically from the WTP through GPRS modem wireless connectivity. When the water level in the pumping MBRs reaches full reservoir capacity, the pumps are automatically switched off, thereby avoiding any overflow of water as there is no manual interface in the pump's operations. Each MBR, GSR and ESR has a microprocessor controller along with ultrasonic level transmitters, a solar panel and battery backup, an ultrasonic flow meter, an automatic flow control valve at the inlet and an automatic on-off valve at the outlet. By monitoring the data, the operations can be controlled remotely from the master control room at the WTP. When the water level in the MBR, GSR and ESR reaches its designated mark, the intake flow of water gets regulated by the flow control valve and it gets shut off gradually, thereby avoiding the overflow of water and eliminating the probability of water hammer in the feeder mains. As per the schedule of the water supply, the command is given to the on-off valve at the outlet of the ESR. An auto command is given by the controller to shut off the on-off valve by keeping a minimum of 1 meter water level in the ESRs for an emergency such as fire, etc. With its integrated design and automation, the Jalgaon Jamod town and 140 villages regional rural water supply scheme will not only quench the thirst of lakhs of villagers of Jalgaon Jamod and Sangrampur Taluka of Buldana district, but will also set an example of low maintenance, zero wastage and user-friendly automated water supply scheme in rural India.